not conversation, this session, so we can watch it later. Anyway, all right. And here's our agenda for tonight. Starting off with a little Guns N' Roses, getting the mood / behind me, and late breaking news that I've just decided. We are not going to have an exam on Thursday. We're going to have it a week from today. I'm not going to teach anything new. I'm not going to assign any additional Pearson. Okay? Pearson will still be due tonight by 11:59 p.m. unless it crashes again. And if it does, I don't know what I'm going to do, but I'll figure that out. Okay? So what you're looking at on the screen right now has just changed while I've been sitting here thinking about it. The bottom line is on the 7th of April, we'll have our exam. And then we'll go on spring break. And when we come back from spring break, we'll cover new stuff. Alexa?
We can't see the agenda.
Well, that just kind of took all the kind of stuff out of my stuff. Thanks for letting me know. I've done that about times a day. And I'll probably do it about 5 more times. Thanks for letting me know, though. Seriously. Can you see it now?
Yeah.
All right, super. Okay, so this is all null and void anyway. I'll just update it right here in front of you. So we're going to do some more power drive on Thursday. So more of what we're going to do tonight. And then right here will be our exam. Okay? So a few things before we begin. We're already recording. I just put that there to remind myself. Don't worry about this 802 because you are the 801. Pearson. Yeah, Pearson's a mother. What can I say? It's 5:02. We've extended it a couple times now. We're going with 11:59 tonight. If it crashes, I'll deal with that. Otherwise, let's drive on through and get our reps in. I want to talk a little bit about exam 2, but I really want to go on to power drive since we're not going to do it on Thursday. Really what I wanted to talk about exam 2 was more about the logistics of it and how it's going to work. So we're going to talk more about this tonight, what is on exam 2, but more from the perspective of how I want you to think about it and frame problems. And the references are everything you got up to this point. So I'm not going to talk about this much. I'm not going to talk about this because all this is not going down on Thursday. I will say that when we do it a week from today, it'll open on Canvas assignments at 4:50. It'll close at 6:50. It'll be open book and open notes. But as always, I'm more concerned that you're mindful of time. Okay? Because if you're heavily reliant on your notes, it's going to eat your time. You should have notes. You should have a formula sheet. Who in the world memorizes this stuff? The point is not memorization anyway, but there's a difference between looking up a formula when you know how to use it and being over-reliant on stuff, okay? Cutting and pasting is not allowed. I don't think that's going to be a problem with this exam because I don't know how you could do that. And when we actually execute the exam, I'm going to have 2 ways of being there for you. I'm going to have a Zoom up so you can Zoom in and ask me a question, or you can call me, okay? Machete doesn't text. I don't text. I do text, but I don't think text would be appropriate for this. So you've got one of those 2 ways. Again, when we do the exam. Just to get you in a mindset, here's what the exam is going to look like. And all this stuff I'm going to upload to your Canvas when we finish tonight. I got a little bit of a backlog to do, so there's going to be a little bit of a lag time, but it matters less because this is a week away at this point. So your exam packet is going to be an Excel spreadsheet. Let me orient you first to this yellow box up here. So you'll have a tab for every problem set on the exam. And you'll know that it's a different problem because you'll have a different color box up here. This box will refer to your narrative. I'll put any kind of data up here, like a table. I don't think we'll have any tables for this exam, so that really won't apply. Of course, you'll have to figure out what's going on within that narrative, what the givens are, those kind of things. Then you'll have your questions down here. For the straightforward questions, you'll put it right here in this gray box. How many licks in a Tootsie Roll Pop? Put it right here. Who's the lead singer for Metallica? Put that right there. That kind of thing. Now you'll have some conceptual stuff and you'll get a bigger gray box. Do you believe in the concept of infinity? You'd start typing away down here. Again, I'm not going to ask any of these questions on the exam. This is just to get you in a mindset of what this looks like. So I also put a little finish line down here so that you don't have to guess, okay? 6 questions, no more. I'm done with that. Now, over here on this side is where you'd show your work. If you're an Excel person, get your Excel on. You got unlimited space here, essentially. You can cut stuff from over here, data, use it over here, whatever. If you're like, hey, I don't want to roll with Excel, I just want to do this manually, then I do care what you do, but you can do as long as you meet the intent, meaning you can write out your stuff on a sheet of paper. Can't see that so well. Slash is just overriding my sheet of paper. And then you take a picture of that just as long as I can read it. Okay. And you could either paste it right here or you could just email it to me directly. Okay. In the end, I'll figure it out as long as you didn't do this exam in a closet kind of thing. What else? So you get done with this, you save it all, you upload it to Canvas, you send it in before the time's up, and we're all good in the hood. Okay? So I want to recap and then pause and ask for questions because some folks jumped on after I had begun. In short, this is what the exam will look like when we take it right here. I'm going to post this on Canvas tonight so you can look at it some more, kind of let it soak in. If you want to do things manually, that's cool. When the time comes, you'll take a picture of it. The big news is that while Pearson is still due tonight at 11:59 p.m., we are not going to have the exam on Thursday. We're going to have the exam a week from now, and then we'll go off on spring break, and then we come back, we'll pick up with block 3, hypothesis testing, and the stuff that goes with it. I want to pause right now for any and all questions you might have before we continue, big or small.
Wait, so you moved the exam to next week?
Yes, I'm moving it from Thursday to Tuesday.
Now, what if we don't finish in the time frame? Is it like point off every minute or something like that?
Why do you think you wouldn't finish in the time frame?
Just a curiosity, just in case XYZ happens.
I don't know. I mean, I think I'd rather address why we think we couldn't finish in the time frame than what's going to happen if we don't.
Okay.
So, and I don't mean to, I'm not Cameron. I'm not like playing guessing games.
No, I get you.
You know what I mean? Some folks are concerned about the amount of time it takes doing certain things. You know, those are the discussions that I'd like to have as opposed to, you know, what happens if I don't make it, kind of thing. You know, so turn the question around and let's talk about why you wouldn't make it and how I can help so that you make it. And in some instances, that may mean that I have a larger time window, but I'd want to kind of have that discussion first.
Okay. What if like say internet or something happens to shut off in that time frame?
Yeah. So I guess the way I would answer that is I guess we could put that in two buckets, whether the internet affects me posting it. I guess three buckets: the internet affecting me posting it, the internet affecting you downloading it, and the internet affecting you uploading it. And of course, in the end, you know, you can what if anything. And I don't mean to be facetious. If the internet affects me uploading it or it going out on time, then obviously I would put out one of these flash announcements that adjust for that. Of course, I'd probably have a hard time putting out the announcement because we'd be in the middle of blackout. But I would do that as soon as I could get that out to you. Assuming that doesn't happen and you have problems downloading it, I guess I would, if I was going to weight my odds, I would try to be there right when it opens to download it. And then if you have trouble uploading it, then I don't know. I mean, I think the first thing that I would want to do is hear from you some form or fashion, even if it's a phone call. Assuming that Zoom and email and everything can't go, which is, hey, my Wi-Fi is out and I can't send it to you. And at that point, I really don't have too much choice but to take your word for it that that's really what's going on and that you would get it to me as soon as you can. That kind of thing. Now, if that's, you know, I mean, that's not a, I don't know if that answers your question, quite honestly.
It does. Thank you.
I mean, if you've got a problem and you can't let me know that you've got a problem, and I think all of you have been very good at letting me know when there's a problem, and I sincerely appreciate that. And thank you for that. But if you've got a problem uploading something, then I think first step is to let me know you've got a problem uploading something. And then we go from there, kind of thing. So other questions? Okay. With that in mind, at the risk of preaching, I just will say that I won't go into all the reasons that I feel like the test should not be Thursday. I would give recommendations on how we and you should spend the time between now and Thursday. And of course, I never mean to imply that this is the only show in town, because it's not. I know that this is one of many shows in town in your lives. And I just want to say that I appreciate and respect that. Jobs, other classes, other things. But I think my thoughts really don't go different than anything we're about to do tonight. So let's go to this, our beautiful power drive. And what I'm going to do is show my screen again. Okay, so first of all, our power drive. I'm going to post, in addition to the video of recording tonight, I'm going to post This, at a minimum, sterile. So all the problems that you see on here, so you could work this again. We'll get through as much as we get through this tonight. And so you'll have that in terms of solutions. And then we'll go from there. But this first slide, I'm going to steal a little bit and talk about these things. And then from this point on, we'll go into kind of a we drive kind of thing where I ask you questions. I throw a question up on the screen, and then anything goes. I ask anybody out there. And as always, it's our safe, happy place. We're all penguins. There's no wrong answers. And no one should, quote, feel bad because they don't know how to do something. That's what this is all about. But I first want to talk about a few things. And what I think I would like you to listen to this part as an assessment of where you are in this process. Okay. So first of all, this analogy kind of goes to a smoke jumper analogy, and you don't need to know what smoke jumpers are kind of technically. This is the worst helicopter probably drawn to date kind of thing. But smoke jumpers, like in California, they parachute into forests and put out fires. And so the big thing there is you don't want to jump into the wrong forest, because if you do, then you're going to be solving a problem that doesn't exist when the real problem is somewhere else and you can't get to it. So how does that analogy work here? Well, in block 2, okay, what we've done since the last exam, we could see it as 3 forests. All right. And this is really important when you go, and I know a lot of you are challenged, and this is okay. What problem am I trying to solve? So that's the point of what I'm about to go through. Well, we have single value X problems. And in those type of problems, we are dealing with one value, one ball bearing, one, one person's weight, those kind of things. Think of single value X, the mysterious X villain that's going to fight Batman. He doesn't know. Okay, so that is one big forest. Another big forest is the sampling forest. Okay, where we're taking samples of things, usually because we want to see how our particular part of the world or the process that we're examining, we want to match and evaluate its performance against the larger population. And then finally, we have the confidence interval forest. Okay. And there, the whole point of this is we're trying to take an estimate on some things about the population. So it's kind of like taking our sampling world and turning it in reverse a little bit. Okay. So the first thing, and I've talked to other folks today, is, and we're going to do some of this tonight, when you look at a problem, before you jump into a forest, you should make sure that you can identify what type of problem it is. And sometimes you might have a problem set and you have to do some time in one forest and then jump into another one. Okay. And that's all good. You just want to know where you're at. Okay. So again, there is no right or wrong with any of this. If what I'm talking about, you're like, dude, really? You said this 10 million times. I got it. That's cool. If you're like, this is still all Greek to me, it is what it is. We need to identify where we're at so we can build from there. Now here, what I'm going to write in red now is some subforests. Here, all we're going to deal with is X, single value. Okay. We might have it. We might not. We'll get to that in a minute. But all we're going to have to deal with is X here. Now, in the sampling forest, we actually have one subforest where we deal with sample means, X bar. Okay. And then we have another subforest where we deal with P, sample proportion. Okay. So, sometimes we get here, okay, I know I'm in the sampling forest, but then we get confused on these. And there's keywords and ways to guide ourselves there too. Okay. And then confidence interval, we're dealing with the opposite of these. So the opposite, or not opposite, but the bigger brother of X bar is population mean, mu. And the bigger brother of P, remember that's not P bar. There is such a thing as P bar, but that's not what that is. The bigger brother of P is what I call P pop, which is the proportion population. Okay. And then we can further divide this into what types of problems we have. And those are the trees. And again, the analogy I make, so the smoke jumper jumps in the forest, they know the subforest, but they need to focus on the tree they need to chop down or whatever to stop the fire. So here we could have X, and we're trying to figure out what the probability of X is. Okay, so we have the value for it, 49, 56, whatever, and we're trying to figure out what is the probability of that respective X. We have some variations of this, and we have some variations of this other one, but these are the main problems. The reverse of that is another problem or a tree that we could have, which is where we're given a probability and we have to find X. And in my experience, both personal and just observing warriors, this is the tougher problem to do 9 times out of 10. If folks are going to struggle, they're going to struggle with these, myself included. Now, as we go down assembling, now before I do that, let's go down here. Now, a variation of either one of these is what I call the in-between. Okay, or the interval, meaning I have two values for X. Let's say I have 49 and 50. What is the probability of X falling in between 49 and 50? Okay, so that's really this problem. I just do it twice. Okay, and that's what I call an in-between to figure out that interval. Or I might have this kind of problem, and that might be an in-between. And then, of course, I might have a symmetrical in-between. And we'll talk about some of these tonight. Okay, but the methodology, once you kind of understand, these all go hand in hand. They're not the same problem. They're not the same tree, but they're in the same ballpark. So really, the core to all this and you building strength is identifying patterns and where you struggle. And once you can do this, now we can surgically address that. And that's what this is all about. Okay. And I've seen this. Folks are like, man, I don't know what I'm doing. I'm like, you do. Actually, if we pinpoint right here, it's with this. And so it's just like anything else in life. If I'm doing some kind of Olympic, if my golf swing is off, it's a horrible analogy because I hate golf. There's good golf coaches who can step in and say, hey, just change this one little thing. And maybe I'm not so far off. All right, moving right along. The good news down here is that these trees look a lot like these. Okay. So I might have a sample mean and I need to find a probability. Or I might have the reverse where I have a probability and I need to find a sample mean. Okay. And then when I go down here to proportion, same. I might have a proportion, need to find a probability, or I might have a probability and I need to find a proportion. Okay. Now, I know you're thinking, okay, this is kind of messy on the board. It is. And this is still conceptual. Okay. And what we want to do, definitely one of our next steps, okay, after we get through the mess of Pearson, but maybe along the way, is to get prep for combat. So we've got to get our formulas categorized so that when we frame, we figure this out, we can go straight to that formula and just terminate with prejudice. Okay. And that formula sheet, what your individual formula sheet looks like, I have some that you can look at. I have some that you can copy. But here's the deal. At the risk of making an analogy that sounds overhyped and doesn't resonate, I don't go into the arms room and take anybody's weapon to go fight the war. I go and pick my weapon. And the thing about my weapon is it's mine, and I've shot it many, many times, and it's sighted to me. Because where Travis puts his face on the weapon is different than where I put mine. So if I use Travis's weapons, I might not hit the target. But if I use mine and I've practiced and rehearsed with them, I'm going to hit the target. So your formula sheet, I can give you examples, and I'm happy to do that all day long, but I would encourage you to recopy it until it becomes yours. And that doesn't really take very long. Anyway, back on track. Confidence intervals, we'll finish this out. The easy one of these is this dude right here, where we're trying to estimate a confidence interval for P. So we're just going to give him a tiny little space. The $500,000 question that I always talk about is down here with the population mean. The $500,000 question is, do I know sigma, which is the standard deviation for the population? If I do, I'm going to use Z. And I have a set of formulas for that. If I don't, I'm going to use T. And I have a set of formulas for that. The good news is with P, all day long, I'm using Z. So I don't have to worry about this decision if I'm down here in this subforest. Okay. The decision is when I'm dealing with the population mean, I have to answer the question in this $500,000 question. Okay. So again, slow is fast. If you're like, I'm just lost, I don't know where to start with all this, assess yourself. How good do you feel about grabbing a problem? Okay, just imagine a giant slot machine of problems. You pull the handle, a problem comes up. How comfortable are you, and this is rhetorical, in framing and saying, oh, it's this, or it's this, or it's that? Okay. Again, scale 1 to 10, 10 being great, badass, 1 being, not like I'd want to be. Depending on that, we keep on going. Maybe I feel pretty good. I feel like I'm an 8 here. Okay. How good are you in identifying the subforce? Pull the slot machine. I could do this. Can I do this? Okay. How good am I identifying the tree? Okay. And again, there's no right or wrong. It's where you're at. But if you don't know where you're at, as the saying goes, any road will get you there. Meaning you'll be soup sandwich. Okay. Nobody wants to be soup sandwich. We all want to be mad skills. Okay. And then out of that, of course, at the end of this rainbow is your formula sheet, adjusted, fitted, tactical to you. I could take Connor's formula sheet, line it up next to Alexis's, and it could be all sorts of different orders. The formulas shouldn't be different, but Alexis might have some stuff in one spot or Connor has some stuff in another spot. At the end of the day, I really don't care. Okay. I'm not going to tell Connor to hold the weapon a certain way and Alexis to hold the weapon the same way if they're just both knocking down targets. I'm going to get out of the way and watch the fun. And with that, let's jump into some fun. So Take a look at this. I'll read it out loud while you think. If the mu, the population mean, is 100 and sigma is 5, 75% of the sample means will be less than what value? The sample size is 16. Okay, so think on that for a minute. Don't try to, quote, solve the problem just yet. What I want you to do is think about what type of problem it is and how you would begin to solve it. Okay, just for a few seconds, and then I'm going to call on somebody. And again, we're all penguins here. This is our safe spot. So if you don't know, you don't know. Give it a good guess. If you don't want to do that, that's cool too. It's all learning. All right, Alexis, why don't you start us off? What do you think? How would we go about starting to solve this? I think you're on mute.
Is it a sampling problem first?
Okay, I'm having a little bit difficulty hearing you, but I think I hear you say this.
Yes.
Okay. All right. What else you think?
Um, would we figure out the sample equation? And
Okay, Lauren, what do you think?
You have to check if it follows normal distribution.
Okay, super. Let's assume it does.
Then you would use. Would you start with the mean minus the mu over standard deviation? And then
Yeah, go ahead.
you do the radical of n.
So that would actually, if we had the value, we would do that. But in this case, the challenge is we don't know the value. Okay, but we're on the right track. This is the right forest, our sampling forest. Lauren, what subforest are we in? Mean or population or proportion?
Mean,
Super. How do you know that?
because it says sample mean.
There you go. I'm telling you, others have not picked up on that today. Another thing is we have this. So we have the big brother of the sample mean. You see how that reinforces that? So, Colin, what do we do with that?
Is that the probability?
That is the probability.
So we would find that on the C table?
Yes. Super.
Alright.
And would we look for 75%?
You would look for 0.75?
0.75. Now, before we do that, and that is correct to do, one of the things that I've found is helpful with this type of problem is what? What do you think, Alexa?
Like draw the curve and like picture where it would be to figure out like what the lesser percentage would be.
Super. So let's roll with that. That's just what I would have said. So if I'm talking about 75% will be less than what value, I'm going to draw a line of whatever this value will be. I'm going to draw that somewhere. I'm going to draw a vertical line. Where would I just start to draw that line? Would it be here? Would it be here? What do you think? 75% will be less than a certain value. Think about that area under the curve equals 1.
It'd be to the right.
Okay, so like somewhere over here.
Yeah.
So this is going to be 75%. So this X is going to be somewhere in there. Okay. I've found that this is very helpful to draw, because if in the end I get an X, and in this case, the mu is 100. So if I get an X that's less than 100, I didn't do something right. Okay. All right. So method-wise, I'm either going to go to the Z table and find 0.75 and turn that into a Z score, or Matt, what else? How else can I take that 0.75 and do something with it?
You can use it in the formula, which I don't know off the top of my head, but
That look right?
yeah.
So if I enter this, this will give me a Z score that should be positive. Okay. And I don't know what that is off the top of my head, but I know it's, I don't know what it's going to be. If somebody's got it, it matters more about how we know what we do.
I got 0.674.
0.6. Okay. That sounds right. Okay. Why do I think that sounds right? What's a Z score for? If I converted the mean into a Z score, what is that Z score? Travis, what is the Z score for the mean? Regardless of what the mean is. The Z score for the mean is what all day long?
It should be 0.50 or 50% of the table.
Okay. So the probability is 0.5. The Z score for the mean is 0.
Oh, yeah, my bad.
Okay.
I have a question.
Okay.
So if you're doing it like not in Excel and you're looking at like the physical Z table, would you pick, because there's the two values are in the Z table are 0.7486 and 0.7517. So would you just pick the 0.7486, or would you have to find the average of the two and like see if that's closer?
Yeah. So for Pearson, there's going to be times where you have to take an average. For everything we do, I'm going to give you a clean value.
Okay.
Okay. Because it's, my fascination with you fighting the Z table ends by that kind of thing. So I didn't look this up before I wrote the problem, but I would give you something here that falls on a clean value. Does that make sense?
Yeah.
Okay. So, all right, whatever that Z score is, let's say that it is 0.674. And remember what Z scores are. Z scores are how many standard deviations a value is to the right or left of the mean. So this looks correct. We know it's positive. That makes sense because it's right. So remember this 0.674. I just need to get some more room here. I'm going to take that 0.674. Okay. And now what do I do? Let me call from, every time I do that, it restarts me over here. So Delaney, what do I do now with that? With this value right here, what do I do with that?
Okay, so with the value, think there's a formula you have to plug it into.
Okay. What, Ryan, what do you think that formula is? It's going to be something like this because I'm solving for X. That's what that is. It's X bar because like Lauren said, from Jump Street, it's sample mean, which is what X bar is. So how does my formula continue, you think?
You take the value minus the mean and divide that by the sample size. Or I know there's like something with square root of n.
Okay. So Ryan, what you're talking about is if I have a value and I want to determine the probability, but here I'm doing the reverse. Jenna, what do you think? What do I want to do with this?
I'm not positive, honestly.
Okay, then be semi-positive.
I think I might have found it.
Okay.
So is it going to be X equals Z times the standard deviation plus M?
We're on the road. Tyler, what's missing from this formula?
Honestly, that's the formula. I thought that was right.
Okay. Tim, what do you think?
You have to divide it by the square root of the size, the sample size.
Okay. Divide what by square root?
Sigma. Yeah, sigma.
Okay. That is correct. So let's see here what values we had. We have 100. Okay. Carrie, what's the value for this dude?
Sorry, I was muted. Is it 5?
It is 5. So that's going to be 5. Tyler, what's the value for n?
Sorry, 16.
Okay. So that's 16. And like Cameron said, this is 0.674. Now, before we do all these calculations, Alexis, is X going to be greater than 100 or less than 100? Greater than, because this is a positive number. There's nothing negative about this. That's positive, that's positive. So it'll be greater than 100. And so we know that whatever this is, assuming we did our computations correctly and we got this number correctly, is going to be the correct number. Because remember, on our little diagram, this value is to the right of the mean, and the mean is 100, and our value is somewhere out here, and 75%. So it's 75% will be less than this value. So it would make sense that it would be greater than 100. Okay? Now that we've been through all that, let's take a look at this one. Okay? If the mean is 100 and sigma is 5, there's a 75% a 75% probability that X will be less than what value? So again, let's kind of reset in place. First, think about the forest. Think about how you would approach. Okay. Anna Grace, what do you think? What kind of problem is this?
Oh, sorry, I was on mute.
It's okay.
Probability. I'm looking through my notes. Let me see. I would say, well, when I look at this problem, like, how do I find out what I'm trying to find?
Yeah.
Like, am I looking for the probability or?
Yeah. And see, these are all fair questions. This is what I want to get out of you. So you're given the probability. There is a 75% probability.
Okay.
So you have that. What don't you have?
We don't have standard deviation. Oh,
We
yes,
do.
we do.
Yeah.
We don't have X.
Yep. We don't have X. And Anna, Grace, is this a sample mean problem? Is this a proportion? Is this a single value? Which forest are we in? Are we in single value problem forest? What do you think?
Yeah, we are.
Okay. And what you're correct. Why do you think that?
Because we're not looking for X bar, we're looking for a single value of X.
Very good. So all these things in Anna Grace, you know, it's kind of like keywords. There's no X bar here. It's single value. Okay. So that's a giveaway. The fact that we have X and we know we're dealing with single value X. We don't even need to reinforce that. Now, this is the tricky part. And I have seen folks mistake this for some kind of proportion. All right. But, you know, just slow is fast. Probability, 75% probability. So probability is not proportion. Okay. So to start out, we know we are in the single value X forest. And the tree that we're chopping down is this kind of problem where we have probability and we want to get what that single value X is. Okay. So Matt, what do you think? What are some of the things we could do next? There's a number of things. What do you think?
Since we already figured out the Z value for the 75% probability, you just take that Z value and plug it into the formula.
Okay.
Which is Z times standard deviation plus mu.
Okay, so Matt is correct. Remember, this is the formula for single value. Notice there's no n here because n is 1, and the square root of 1 is 1. Matt is correct that the probability is still the z-score is the z-score. So what I would do, just to be, you know, still bulletproof, is I would still draw the same diagram. But here's the thing I want to key in on. The diagram doesn't change. Just the same way Matt's probability and the z-score don't change. So I'm going to put my hack mark out here for all the same reasons. 75% probability, it's the same thing that X will be less than what value? X is going to be this value or less. So that's that 75%. If it was or more, then it would be a different problem. So I just got to find what that is. And I can find that the same way we did before. I could go to the z-score table, or I could enter my formula off my Excel sheet. Remember, that Excel sheet is only good for single value, but since we're in single value land, I might as well use it. Maybe I put 0.75 in that and I get out that z-score. I put that in there. I have sigma, I put right there. I have my mean, I put right here. Okay. The value that we get for this answer is going to be different than the value we get for the previous problem. And the reason for that is I don't have the square root of n down here, and I did in the other problem. But notice the commonality in the pattern. That's why I did this. Okay. I want you to see what's similar, if not the same, and what's different. Okay. So that you can, again, exploit those commonalities. All right. Let's look at another one. Okay, shifting gears now. Okay. So, Ricky, for some reason, if I was in a classroom, I would bust out with, "Oh, Ricky, you're so fine," that old song, but I'm not going to do that here. Essentially, I just kind of did without doing it. Ricky is betting on the horse Hot Mess. He knows that Hot Mess usually completes its race in 9.75 minutes with the standard deviation of 0.04 minutes. And before we go on, like Lauren expertly pointed out in the opening minutes, we're going to assume that Hot Mess's performance in this race follow a normal distribution. Okay, so let's let that sink in for a little bit. So, Connor, what type of problem you think we're dealing with here in terms of forests and all that kind of stuff?
Would it be single value X?
Super. And why do you say that?
Well, you're given the mean, you're given standard deviation, and you have to find the probability given.
Okay. So for this first one, Connor is correct. What is the probability that Hot Mess will complete the race in less than 8 minutes? So Jenna, just how would we approach this?
So would you use the formula x minus m over sigma?
Mm-hmm. Okay, so let's go ahead and take that. You are correct. So Chastity, what would go where in that formula? I'm just going to draw it out here. Okay, again, formulas are good if we know where everything's supposed to go. And Jenna, what at the end of the rainbow, what are we going to get out of this formula? What is that value going to represent?
So that would leave you with the z-score, I believe.
Very good. Believe, warrior, believe all day long. It's true. Okay. So Chastity, this is correct. So what values am I going to put where?
So X would be 8, 9.75, and then 0.04.
Okay. And I would get a z-score, and I would go to my z-table and look up what that is. Okay. I actually think it's like really ridiculous, like negative 43 or something like that. And we know that the end of our z-table is negative 3.6 to the left and 3.6 to the right, which means if we have a value less or more of those values, the probability is less than 0.001. Okay, remember the tails of the z-table, or excuse me, the normal distribution goes in either direction infinity. And so we have an infinite amount of probabilities, but it all adds up to 1. Even though my dad doesn't buy all this, but I do. Okay. Now, just to reinforce success, if we were going to draw a picture of what's going on, my mean here, and I'm going to draw so my 8, this is 10, this is 9.75. And 8 is somewhere down here. This refers to this down here. Okay, that's the probability we're solving for. Small number, small number. Okay? So, Carrie, how about this one?
I set it up as z equals x minus mu divided by sigma, and then when you get your z score, you would subtract that from 1, right?
Okay, good. All right, so we'd put what where? Tyler, what would we put where based on this formula?
So x is gonna be 8 or 10, sorry. 9.75 and then over 0.04.
Okay, super. And then that gives us a z-score. Like Carrie said, we're going to go to our z-score table, find that probability. And whatever that is, we're going to take a 1 minus. And here's why. Let's draw the picture real quick. Let me get this out of the way. So that 975 is still smack dab in the middle. 10 is somewhere out here. Okay, and I'm solving for this. Okay, so if I don't watch out, if I go, I'm going to find that z-score, but if I don't do a 1 minus, that 1 minus, or excuse me, that if I don't do a 1 minus, that probability, whatever it is going to refer to this. Okay, as if this said, what is the probability hot mess will complete the race in 10 minutes or less? But that's not what I want. I want or more. So that's why I'm going to do that 1 minus with whatever I get, which is what Carrie pointed out. Okay, good. Let's keep on rolling with this last part. All right, to maximize his chances of winning, okay, Ricky's bookie, I put betting agent because I don't know how many of you know what bookies are, and nor that you should for that matter. So Ricky's bookie is saying this, hey man, I will give you a 1 minute spread anywhere you want, okay, for your bet. All right, so it could be from 7 to 8 minutes. The hot mess is going to finish somewhere in between there. It could be from 10 to 11. Okay, where should that be? Where should Ricky pick and place that interval to max out his chances of winning? What do you think, Alexa?
Between probably somewhere like close to the mean.
Okay, that's a good start. That's definitely on the right track. So why do you say that?
Because as you get closer to 8 or 10, like farther away from the mean, the probability is low.
Okay, so Colin, building on Alexa's answer that the mean is 9.75 and Ricky's agent has given us a 1 minute spread, how should we build that interval, do you think?
Take 9.75 minus 30 seconds and 9.75 plus 30 seconds.
Yeah. And a simpler way to do that, but same thing, is to add 0.5 on this side, 0.5 of a minute, which is what Colin just said. I'm just saying it another way. And to subtract 0.5 on this side. So that value here would be 10.25 minutes, and it'd be 9.25 minutes on this side. And Colin, why did you say that? Why would we go equal distant here and here? Why wouldn't we have more on one side or more on the other? I think Colin fell out. Matt, what do you think? Why would we build this way?
Because it's symmetrical on both sides. So you want to get the most likely probability from both sides of the graph.
Yeah. And another way of saying that is look how high it is right here. Okay. And that high, that area is the biggest. Okay. So let me show you an alternative, which is not the way we would do this. And everything that everyone said is correct. I'm just building on it. So we talk about central tendency, and the higher n gets sample size, the more performance is going to center around the mean. This goes back to earlier discussions we've had on average, okay? And so definitely with a standard deviation like this, you look at that compared to this, that is not much at all. This means this horse is really tight around that 9.75, even though it's got a name called hot mess. So if I took an interval, let's say here, all right, so between this time and this time, look at how little that area is compared to the red. Okay. And I want the biggest space because the biggest space is the biggest area, and the biggest area refers to the higher probability. Higher probability, more chance that that horse is going to run the time that it's supposed to. And then assuming that that's a good time, that it'll win. Okay. So that's why we build from the mean outward equally on both sides, is because we want to maximize that space and maximize the probability, because that's where the highest part of the curve is. Okay. Good job. Let's keep on rolling. All right. Okay. John asks his Instagram followers, hey, how many of you heard of this coronavirus thing before February? Out of 450 people who respond, 200 say, yeah, I heard about it. So a couple questions to get us started. First, what is the proportion of people who had not? Second, if John wants to determine a 95% confidence interval for people who had not, what would he do? Okay. So Travis, if we're talking about this right here, the proportion of people who had not heard of coronavirus before February, what would we do? How would we determine that proportion?
Well, wouldn't you need to figure out, so you need to take 200 and subtract it from 450 to figure out how many people didn't know what it was?
Absolutely. So that would give us 250. And then what would we do with that number to find out that?
Wouldn't you do the would you do wouldn't it be would it be like P plus or minus the Z?
Okay. You're skipping ahead a little bit. I like how you're thinking.
Okay.
Okay. Before we get to that, first we got to figure out P. We got to do something with this number here. Don't think too hard.
Oh God.
Run at him. Run at him.
Is it, do you have to go to the T table?
Run at him. Run at him. Connor, what do you think?
You have to take 250 and divide it by 450.
Oh, I mean, yeah, you could do that too. That works.
All right. It's all good in the hood, man. Okay. So, Lauren, once I have this and whatever that is, okay, what am I going to do with that? Travis got us started. Okay.
And
So,
then you get the 95% confidence interval.
yep. And how am I going to do that?
You go to the table with alpha half, right?
Mm-hmm. So, what
And
is
then
alpha half?
0.025.
Outstanding. And which table am I going to?
The table, the confidence interval one.
Okay.
Critical value, right?
Yep. So what's that z-score I'm going to use that corresponds with 0.05 or 95%?
1.96.
1.96. Very good. Okay. So let me get some different colors going. I'm kind of getting sloppy here. That's my fault, not yours. All right. So Travis got us started on this bad boy. Confidence interval. We're talking about, I think by now we know this is a proportion problem, and we're in the confidence interval forest. Okay, so confidence interval forest, proportion subforest. The beautiful thing about this forest is we've got one table like Lauren identified, critical value. We have a hack. Okay. The technical term for the critical value table is the Mike TV table. I'm just kidding. I made that up. But here 1.96 is what we're going to use for Z. So like Travis said, our formula P plus or minus Z times the square root of that right there. Okay. So P is whatever this is equal to. Okay. And the bottom line, so let's just put this into context. Alexis, I know this is P, but what type of P is that? What did John do? And this talks about what he did, but what do we call this? Starts with an S. You're on mute.
Is it sample?
Okay, I can barely hear you, but I think you said he took a sample, which is correct.
Yes.
Super. So he took a sample. He said, I wonder. So he went to his little piece of the world, which is he got some Instagram followers. I know that doesn't seem like much, but that's like twice as many as I have. You all could help me. Anyway, so he took a little sample, and that's what P is. It's a sample proportion. And then he used that to make an estimate on what proportion people, okay, heard about the coronavirus. All right. So he's going to put P in there. Not that. P is not going to go in here. Okay. I don't want that to point to that. I want this to point to that. So he's going to put that P in there. He's also going to use that same value P right there, and he's going to use it to do this. Anna Grace, what is John's N?
Sorry, I was on mute. His N is going to be 450.
Outstanding. So he's going to put 450 there. And like Lauren said, he's going to put 196 right there. Okay. So he's going to figure out what this mess is. He's going to park that somewhere. He's going to add it to P. And that's going to give him his upper value. And then he's going to minus it from P. That's going to give him his lower value. And I'm not going to do all the math here, but I am going to. So in the centerpiece, so let's see here, rather than me doing this, Ryan, so talk me through in the end what his confidence intervals should look like. Don't worry about the specific numbers. Just kind of walk me through it.
You mean like the formula?
Well, we just covered the formula, but what it will look like. So once we're done, what is his, what should it look like in terms of the end zone?
It's going to be more on the right side, isn't it?
Actually, it's not. Confidence center, the whole point of this is conceptually what we're doing is we're saying, hey, we don't know what the population proportion is, but we want to capture all the means that go this way, half of 95%, and this way, half of 95%. Okay. And so we're going to cut this thing off. We're going to have 2.5% not covered there, 2.5% not covered there. That equals 5, and that means 95 is covered here. So let's see. Tyler, walk me through just what this interval should look like conceptually. Tyler gone? Tyler's
Yeah.
still there?
Yeah, I'm here.
Okay. I have to switch screens, so sometimes I get a little misoriented. So what do you think?
Oh, there it is. Sorry, I couldn't see the work on the screen. I'm not too sure for this one.
Okay.
I have the formula sheet here. Oh, wait, is it I don't know if this is right, but X plus or minus, oh, yeah, Z, and then in brackets, I think that's this mean over N, the square root of N.
Okay. Now we're overthinking this a little bit, folks. Okay. Remember, we have this. It's a proportion plus or minus Z times all this other stuff. I'm writing this backwards, but I'm going a little fast because we're about to run short on time. Okay, Tim, in the middle of this interval, what is the center of attention of this interval?
Is the center of attention going to be the proportion?
Yep. Proportion of the population. Okay, we don't know what that is. That's the whole point of this, is we're making an estimate. Okay. We know that that's going to be less than or equal to some value. The value, when we take P and add it to this mess, that value is going to go here. Conversely, it's going to be greater than or equal to a value. And when we take P minus this mess, that value is going to go here. Okay. And so let's just suppose that, I don't know, and these are going to be decimals because we're talking about proportions. So let's suppose that this is 72 and this is 55. That means that John would say, wow, the proportion of people in the population that did not know about the coronavirus before February is somewhere between 0.72 and 0.55. And that interval captures 95% of the possible values for the proportion population. Doesn't capture all of them because it's not possible to do that, but it captures 95% of them. At this point, we're just going to stop here. Let me get out of that. Sorry, I accidentally did this extra. Why is that doing that? Okay, we'll just stop here. I don't want to burn more of your time. I'm going to hang out on the call for those that want to continue to ask questions. When everybody clears, I will start doing what I need to do in terms of posting this and all the other things. If you have questions, please either stick around, ask them, email them to me, whatever you feel comfortable with, and we will drive on. Sometime here in the near future, you will get the video of the session. You'll get a sterile copy of this, and eventually you'll get all the solutions. I don't know about all. You'll definitely get all the ones we worked through tonight. I may save some of them so that we can do them on Thursday. Okay, with that, if you don't have a question or a reason that you want to hang around out now, I will see you on Thursday. Take care.
So on Thursday, we're just like continuing to go over all this.
If for lack of a better plan right now, yeah.
Okay.
What I'm not going to do, what we're not going to do on Thursday is cover new material.
Okay.
So I'm not going to introduce hypothesis testing or anything like that. And we're obviously not going to, well, not obviously, we're not going to have the exam on Thursday.
Yeah.
Okay. I want you guys to get more reps. And, you know, Alexa, that's an individual choice on how people use that time.
Yeah.
So if you need it, you need it. If you don't, you know, that's that.
Okay.
You know what I mean? Does that answer your question?
Yes.
All right.
All right. Thank you.
Yep, you bet. Others?
Yeah, I had a question about the extra credit on Pearson.
Yep.
If I just do some of it, can I still get credit, or do you have to do all of it to get credit?
No, what you earn is what you earn.
Okay.
So if that's,
and then
yeah, go ahead.
Validation 2C on Pearson closed last night. I don't know if it was supposed to.
Let me add it to the list to check. If it wasn't, it shouldn't, but I may have missed it because I had 3 other classes I was trying. I'm not going to make excuses. I might have missed it. Delaney, if I closed it last night, I'll probably extend it, you know, to, I don't know. I'm kind of tired of fighting the Pearson thing, but since I'm moving the exam, if I closed it last night, either way, I'll reopen it. If I closed it last night, I'll extend it to sometime other than midnight tonight.
Okay.
Kind of thing.
Okay.
Okay.
Thank you.
All right. You bet.
See ya.
Yep. Peace out.
Okay, I just have one question.
Okay.
So on your first problem that you did, I tried to find the z-score, and I took 0.75, and I looked on the z-table, but I had a different score than anybody else. So I just want to make sure I'm doing it the right way.
Okay. Well, first of all, I know that I'm just going to share my screen real quick. So I can, well, I don't need to share my screen. Let me get out of there. I think I might have to. Let me get out of there. Okay. What value did you get, Carrie?
I had 0.7734.
It was 0.75 we were looking for. Is that right?
Yeah.
And you had, what did you have?
0.7734.
How'd you get that?
Okay, maybe I'm doing this wrong. So, can you see I went from there to there.
Can
Can
you
you see?
move it just in a little bit closer? Yeah, right. Okay, so let me share my screen. I got it, what you did. Remember that 0.75 is a probability. Okay, so what you did was okay, so what you did was you went out here, right?
Yeah.
You grabbed that 0.7 and then you went over 5 columns.
Mm-hmm.
Okay, remember that 0.75 is a probability. These are probabilities.
Oh, so you have to find one closest to 0.75.
Right. And that's
Okay.
that's what Alexis was talking about. So check it out. Stay with me. Stay with me, Rachel. No, anyway, I'm just getting that out of the way.
Okay.
So when I'm down here and I'm looking, I don't see 0.75. That is close, but that's not 0.75. And that isn't either. So the z-score for that falls somewhere in between here. Now, I'm not going to do this to you on exam. This is just too much work right here. So I'm going to give you like something like 0.7486.
Okay.
See how that's clean?
Yeah.
Now, what you want to do now is go do the reverse of what you did. You want to go over here and grab this number, and that would be the first digit of my z-score. And then I'm going to lose my marker, but that's okay. It'll reappear. I'm going to go up here. And get my stuff back. Okay, so these aren't lining up. All right, so I'm going to repeat the process. I'm going to go in here. Let's say that I gave you a probability of 0.7486. So I'm looking, there that sucker is. I'm gonna go over here. See how it lines up with 0.6?
Mm-hmm.
So let me get rid of this. So my z-score, my first digit is gonna be 0.6. And then I'm gonna go up here and grab that 0.7.
Okay. Yeah, that makes sense now.
And then I'm going to
I
use
think I was
that.
just confused because there was only 2 values, so I was just automatically thinking like that part. But yeah, that makes sense now.
Now, if it doesn't confuse you, and if it does, then just ignore it. But on single value X only, I can use the formula in Excel.
Oh yeah, I was trying to figure that out when that one person said that. I was typing it in to try and figure it out.
Yeah, and this is on a sheet that I gave you, and then I hung on Excel. It's on Canvas. The danger of this is, again, it's like a machine gun. If I don't know what the machine gun does, then I can hurt myself.
Mm-hmm.
All right, but if I know what I'm doing, I can enter this value here. and it will give me that value.
Okay.
So I can skip all this madness.
So when I typed that in to my Excel, it said that I don't have enough. I don't know the exact words, but that I didn't have enough filled in. So is there more that I need, like the other numbers from that problem? Should I have had that in there too?
Unless I gave you the wrong formula. Let's check it out.
Because when I would try to use Excel for like the Pearson problems, it did the same thing. So like I don't know if it's just something up with my Excel or if I'm doing it wrong. I've just been doing everything manually.
Yeah, and I mean, if that's been working for you, then, you know, it's one of those balances. What I don't want to do is confuse you, but if there's an easier way that you could, that would work for you. So okay, can you see that?
Yeah.
All right. So here, all it needs is that probability. So 0.7486 will give me a z-score 0.67.
Yeah, I'll have to play with my Excel and see if I can get it to do that. I turned it off, but I'll play with that tonight.
Now, on the other hand, if I do this, so if I do this one, and you know, there's a family of them, but if I do this one, this is something different. This actually gives me a z-score when I have the value of the probability. So, for example, or when I have the value of when I have the value of X. So going back to the problem we worked tonight, where we had, actually, this isn't a problem we worked tonight. Let's say we knew that the mean was 100 and the standard deviation. Well, let's do this one. Remember the horse?
Yeah.
And the horse runs 9.75. So we want to know 8. If he runs 8 minutes, what is that probability? So we enter the value, we enter the standard or the mean, and then the standard deviation was 0.04. And we want to do 1 for cumulative. And that gives us the z-score, which I think here, this doesn't look right to me because that was actually pretty low. I wonder if we do this. Huh. That doesn't look right either. So maybe my formulas are off. I mean, that's, I think it's given a 0 because it's so low. That must be it. Because I take that back. These, okay, start over. Start over. Okay. This is that formula I want. This is going to give me a probability. So it doesn't give me a z-score. It gives me a probability. And that's why it's giving me a probability of 0. Is because the probability of him scoring or running an 8 when he has a mean of 9.75 and such a low standard deviation is just about 0. It's like
Okay.
0.0000 gazillion kind of thing.
Mm-hmm.
But let's take something more reasonable, like let's take IQ. So the probability of my IQ being 110 or less is, I put 110 in here. The standard deviation, or the mean for IQ, let's say, is 100. And the standard deviation is 15. So the probability of my IQ being 110 or less is 0.7475. And that makes sense. You see what I mean?
Yeah, that helps a lot more.
So maybe, Carrie, now remember, the big disclaimer is that this is only for single value X for us. We can't use these for our sampling forest, okay? Because these formulas don't take in N into account. All right. So we're going to be messed up if we do that. All right. But we can use them for single value X, and maybe, you know, that saves us a little bit of headache so that we're not messing around with this stuff.
Yeah, that makes sense.
You know?
Okay. Yeah.
And the other beauty about these formulas is I don't have to worry about, does it fall, you know, cleanly on a value or whatever. I can just enter in any old value.
Yeah, that's what was stressing me out with Pearson. That was a mess.
Yeah, and I don't know. I don't, you know, I feel partially responsible for that. I just, and that, I don't know. So I apologize for that. I mean, Pearson's kind of,
no, it's okay.
you know, unforgiving on that.
Yeah, and the decimals and, oh gosh. Yeah.
Decimals are kind of ridiculous. Just kind of stupid. I mean, I think if you're working in a lab, you know, if you're talking about mitochondria and stuff like that, you need all those decimals. But
yeah,
for probably 95% of daily life, I don't know if it has to be that exact. You know what I mean?
Yeah. So I don't want to hold you up too much longer, but I do have 2 more questions. One, could I get equation sheets from you just to see what yours look like and compare them to what I want to do?
Yeah. So let me do you one better, at least to get you started out. Share time again. Stand by. Things I like about Zoom and things I don't, with this ability to kind of share, is something I like. So can you see the internet?
Yep.
All right, super. All right. So the formulas we just talked about are here.
Yeah, I remember that from the other day.
Okay. And then yeah. So here on tools and tips, Sunday, 29 March, all Batman stuff. You got a couple ones to choose from.
Okay.
See those? So
yeah,
this is one that a fellow warrior made. I didn't want to do that. Sorry.
Oh, you're fine.
That's not it, obviously. Hamster wheel. There we go. So this is one she made. Single value forest, sampling forest, confidence interval forest.
Oh, okay. I like that. That kind of clears up that PowerPoint more too.
Yeah. And speaking of that PowerPoint, you can also look at this one. That's not it. So here, this should sound like a broken record right now, but that's not bad. So there you go. There's some more. And here's some more.
Cool. Okay, I think I'm good now.
So, you can pick your poison. Again, not to sound preachy, I think whatever you pick, I would recopy it.
Yeah.
You're not going to have to turn it in or anything. But again, if I hand you my tennis racket and you go out on the court, that's my tennis racket. But eventually you want to, make it your own.
Yeah, that makes sense.
And so I think the way to make it your own is you recopy it. But you get the idea.
Yeah. Okay. And then last thing. So I started my Way of the Warrior project, and instead of making up my own, I didn't want to make it up because I feel like I would just confuse myself. So I did like a survey on Facebook, and I did on like photography pages because I asked a few different questions, like where people like to take pictures and like if they prefer Canon over Nikon. And then I figured whichever question I get like the best answers on, then I would go off of that one. But is it okay to go off a categorical thing? Okay.
Absolutely.
Just making sure. Okay, cool.
Yeah. Sounds good. Sounds like you're off to a good start.
All right, cool. All right, that's all I needed. Sorry for holding you up longer than you needed to be.
No, you don't need to apologize. All right, Carrie.
All right, bye.
You have a good night.
You too.